So in this video, we're going to show a related rate example, probably an oversimplified example from how you would typically encounter this, but we're doing it just as an intro, and then we'll do things that are more difficult in subsequent videos. So it says, suppose y of x equals 3x squared minus 2x plus 1. Y and x are both differentiable functions of time, and it says find dy dt when x equals 1 if dx dt equals negative 2 when x equals 1. So usually you go ahead and write down the information you've been given. So we know that y of x equals 3x squared minus 2x plus 1. We know that dx dt is negative 2 when x equals 1. And we're being asked to find dy dt. And what we want to remember from video 1 is that dy dt, if we know y is a function of x, we're first going to differentiate with respect to x. So we're going to find dy dx. And then we're going to use implicit differentiation to then multiply by dx dt, which will give us dy dt, the time derivative of y. So to start this out, we just first take, and to calculate dy dt, we first calculate dy dx. So dy dx, take the derivative with respect to x, that's going to give us a 6x right there, minus 2, taking the derivative of y with respect to x. So this right here is our dy dx term, but we need to multiply dy dx times dx dt. So I need to multiply this by dx dt. And that's the rate of change of y with respect to t. And then we're being asked to find dy dt at a specific time. So, sorry, at a specific value of x when x equals 1. So to do that, y prime, we want to plug in x equal to 1, so we'll plug in 1 there. So we'll get dy dt when x is equal to 1 is just going to be plug 1 in for x. So we get 6 times 1 minus 2. And then dx dt is showing up right here. So we just replace dx dt with the derivative of x with respect to t when x equals 1. So times negative 2. And then we just want to simplify. So we get 4 times negative 2, or negative 8, as our value for dy dt.